Austenite, also known as gamma iron, is a metallic phase of iron with a face-centered cubic (FCC) crystal structure. It forms when iron alloys are heated to high temperatures, typically above 910 degrees Celsius, and is non-magnetic and non-ferromagnetic. Austenite is a critical phase in the heat treatment of steel and is the main structural component of many common stainless steels, providing good corrosion resistance and plasticity. Key characteristics. Crystal structure. Austenite has a face-centered cubic (FCC) structure, which is different from the body-centered cubic (BCC) structure of ferrite. Magnetic properties. It is non-magnetic and non-ferromagnetic due to the random alignment of its electrons. High temperature phase. Austenite typically forms when iron and steel alloys are heated to temperatures above their eutectoid temperature. Solid solution. It is a solid solution of iron with other alloying elements, such as carbon, nickel, and chromium. Formation and transformation. Formation. Heating iron or steel alloys to high temperatures above the eutectoid temperature transforms them into the austenite phase. Transformation. The austenite phase can then be transformed into other structures like ferrite or martensite depending on the rate of cooling. Rapid cooling, quenching, leads to the formation of hard and brittle martensite. Applications. Stainless steel. Austenite is a key phase in austenitic stainless steels, like the 300 series, which are known for their excellent corrosion resistance, high formability, and ductility. These steels are used in applications such as cutlery, kitchen equipment, and industrial piping. Heat treatment. It is a crucial intermediate phase in the heat treatment of steel to achieve desired properties.